I3rd. Restore, live within Earth resources. C8. Bottom line highlights. Protect, restore forests. Reduce wood use. Recycle paper. Efficient third world stoves, energy, wood, sun, wind. Sustainable forestry. Reconstituted wood. Equatorial tree plantations. Reforest waste, eroded land. Conserve, rebuild soils. Conservation tillage, reduce herd size. Bring forage to herd. Global clear-cut ban. Regenerate fisheries. Reduce fertilizer, sewage runoff. End fishery subsidies. Protect diversity. Water management, for fish. Parks, reserves. Plant trees to sequester carbon, billions. End deforestation. The Earth Restoration Budget. Reforest the Earth. Protect topsoil, restore rangelands and fisheries, stabilize water tables, and protect biological diversity. Note, forested area is already expanding in the Northern Hemisphere's industrial countries. Reforestation costs. The focus is on developing countries. Seedlings cost $40 per thousand, 4 cents each, $80 per hectare, at 2,000 seedlings per hectare. Planting labor largely voluntary, $400 per hectare including seedlings. With a total of 150 million hectares to be planted over the next decade, this will come to roughly 15 million hectares per year at $400 each for an annual expenditure of $6 billion. Reducing erosion to the rate of new soil formation or below. 2 principal steps. First, retire the highly erodible land that cannot sustain cultivation. The estimated 1/10 of the world's cropland that accounts for perhaps half of all excess erosion. For the United States, that has meant retiring 14 million hectares, $125 per hectare. In total, annual payments to farmers to plant this land in grass or trees under 10-year contracts approach $2 billion. Second, conservation practices on vulnerable land that is subject to excessive erosion, that is, erosion that exceeds the natural rate of new soil formation. Incentives to encourage farmers to adopt conservation practices such as contour farming, strip cropping, and, increasingly, minimum till or no-till farming in the United States total roughly $1 billion per year. The total for the world to retire vulnerable land would be roughly $16 billion annually. Rangeland protection and restoration. UN estimates that it would cost roughly $183 billion over a 20-year restoration period, or $9 billion per year. Improved rangeland management, financial incentives to eliminate overstocking, and revegetation with appropriate rest periods when grazing would be banned. Every dollar invested in rangeland restoration yields a return of $2.50 in income from the increased productivity of the rangeland ecosystem. Restoration of oceanic fisheries. Establishment of a worldwide network of marine reserves, which would cover roughly 30% of the ocean's surface. Estimated range of expenditures centers on $13 billion per year. Wildlife protection. Shortfall in funding needed to manage and to protect existing areas designated as parks comes to roughly $25 billion a year. Additional areas needed, including those encompassing the biologically diverse hotspots not yet included in designated parks, would cost perhaps another $6 billion a year, yielding a total of $31 billion. Stabilizing water tables. Disseminating the results. Work through agricultural extension services. Work through the water users associations. Requires knowledge of the amount of water being pumped and aquifer recharge rates. In most countries this information is simply not available. May mean installing meters on irrigation well pumps, as has been done in Jordan and Mexico. Removing subsidies will effectively raise the price of water, thus encouraging its more efficient use. It will take additional expenditures of $10 billion. Restoring the Earth. Restoring the Earth will require additional expenditures of $113 billion per year. Many will ask, can the world afford this? But the only appropriate question is, can the world afford to not make these investments? Brown's expanded version. Restoring the Earth. We live because Earth's natural systems have been there for us, for goods, ranging from building materials to seafood. Services, ranging from flood control to crop pollination. We are in trouble. Our young are pretty much screwed. Croplands are eroding. Harvests are shrinking. Water tables are falling. Wells are going dry. Grasslands are turning to desert. Livestock are dying. If civilization's environmental support systems continue to decline, civilization itself will follow. Where we are headed, the benefits of resource conservation at the most basic level are still out of reach for many. Ecological and social collapses have reinforced each other in a downward spiral into poverty, environmental degradation, social injustice, disease, and violence. Unfortunately, this situation is what lies ahead for more and more countries if we do not restore the Earth's health. Restoring the Earth, effort of the magnitude and demands of the Marshall Plan, but global, must be undertaken at wartime speed. Now. We don't get to set the time frames. Mother Nature has the clock. Otherwise, environmental deterioration translates into economic decline and state failure, just as it did for earlier civilizations that violated nature's thresholds and ignored its deadlines. Protecting and restoring forests, 4 billion hectares of remaining forests, and replanting those lost, are both essential for restoring the Earth's health, and an important foundation for the new economy. All depends on simultaneously 1. Reducing pressure on forests, and on 2. Reforestation. No forests, no reducing rainfall runoff and the associated flooding and soil erosion, recycling rainfall inland, and aquifer recharge. All depend on simultaneously reducing pressure on forests and on reforestation. Reducing wood use, a vast unrealized potential in all countries, to lessen the demands that are shrinking the Earth's forest cover. Industrial nations, the greatest opportunity lies in reducing the quantity of wood used to make paper. And in developing countries it depends on reducing fuel wood use. Paper recycling. Rates of paper recycling in the top 10 paper producing countries range widely. China and Finland on the low end, recycling 33 and 38% of the paper they use. South Korea and Germany on the high end, at 77 and 66%. US 50% in 2005. If every country recycled as much of its paper as South Korea does, the amount of wood pulp used to produce paper worldwide would drop by 1/3. Paper epitomizes the throwaway mentality, an enormous possibility for reducing paper use simply by replacing facial tissues, paper napkins, disposable diapers, and paper shopping bags with reusable cloth alternatives. The largest single demand on trees, the need for fuel, accounts for just over half of all wood removed from forests. Kenya, wood, solar stoves. U.S. Agency for International Development, AID. A more promising project is the distribution of 780,000 highly efficient wood cook stoves in Kenya that not only use far less wood than a traditional stove, but also pollute less. Also the site of a solar cooker project sponsored by Solar Cookers International. Made from cardboard and aluminum foil, and costing $10 each, cook slowly, much like a crock pot. Requiring less than 2 hours of sunshine to cook a complete meal, they can greatly reduce firewood use at little cost. They can also be used to pasteurize water, thus saving lives. Developing alternative energy sources, key to reducing forest pressure in developing countries. Replacing firewood with solar thermal cookers. Or even with electric hot plates fed by wind-generated electricity. Lighten the load on forests. Despite the high value to society of intact forests, Only about 290 million hectares of global forest area are legally protected from logging. An additional 1.4 billion hectares are economically unavailable for harvesting because of geographic inaccessibility or low-value wood. Of the remaining area available for exploitation, 665 million hectares are undisturbed by humans and nearly 900 million hectares are semi-natural and not in plantations. The Philippines, for example, banned logging in most remaining old-growth and virgin forests, largely because the country has become so vulnerable to flooding, erosion, and landslides. Once covered by rich stands of tropical hardwood forests, years of massive clear-cutting lost the forest's products as well as its services, and became a net importer of forest products. Sustainable forestry. Another way to protect forests, if only mature trees are felled, and on a selective basis, a forest and its productivity can be maintained in perpetuity. 1997 Alliance for Forest Conservation and Sustainable Use. In mid-2005, the Alliance announced a goal of reducing global net deforestation to zero by 2020. Additional forest product certification programs inform environmentally conscious consumers. Sustainable management of the forest, where wood products originate. The most rigorous international program, certified by a group of NGOs, is the Forest Stewardship Council, FSC. Reconstituted wood. Substituting for natural wood as the world lumber and construction industries adapt to a shrinking supply of large logs from natural forests. Where wood comes from. Production of roundwood, logs, on plantations is estimated at 432 million cubic meters per year, accounting for 12% of world wood production. This means that the lion's share, some 88% of the world timber harvest, comes from natural forest stands. 6 countries account for 60% of tree plantations. China, which has little original forest remaining, is by far the largest, with 54 million hectares of plantations. India and the United States follow, at 17 million hectares each. Russia, Canada, and Sweden are close behind. Tree plantations moving toward equator, shifting geographically to the moist tropics. Grain yields tend to rise with distance from the equator and the longer summer growing days. Tree plantation yields rise with proximity to the equator and year-round growing conditions. In eastern Canada, the average hectare of forest plantation produces 4 cubic meters of wood per year. In the southeastern United States, where US plantations are concentrated, the yield is 10 cubic meters, 2.5 tims. But in Brazil, newer plantations may be getting close to 40 cubic meters 10 times. Tree plantations moving toward equator. While corn yields in the United States are nearly triple those in Brazil, timber yields are the reverse, favoring Brazil by nearly 4 to 1. To satisfy a given demand for wood, Brazil requires only 1/4 as much land as the United States, which helps explain why growth in pulp capacity is now concentrated in equatorial regions. Plantations. Plantations can sometimes be profitably established on already deforested, often degraded, land. Can also come at the expense of existing forests. There is competition with agriculture as well, since land that is suitable for crops is also good for growing trees. Water scarcity is yet another constraint. Fast-growing plantations require abundant moisture. Plantation projections. UN Food and Agriculture Organization, FAO, projects that as plantation area expands and yields rise, the harvest could more than double during the next 3 decades. It is entirely conceivable that plantations could one day satisfy most of the world's demand for industrial wood, thus helping to protect the world's remaining forests. Deforested land. Vast areas of deforested land can be used to grow trillions of trees bred for food, mostly nuts, fuel, and other purposes. Nuts used to supplement meat as a source of high-quality protein in developing country diets. Trees grown on this deforested land being converted into ethanol for automotive fuel. Reforesting highly erodible land. Some highly erodible agricultural land in industrial countries has been reforested by natural regrowth. New England's forest cover has increased from a low of roughly 1/3 2 centuries ago to 4/5 today, slowly regaining its original health and diversity. Similar situation exists now in parts of the former Soviet Union and in several East European countries. Millions of hectares of farmland are now returning to forest. South Korea, model forest of world. When the Korean War ended, half a century ago, the mountainous country was largely deforested. Beginning around 1960, the South Korean government launched a national reforestation effort. Relying on the formation of village cooperatives, hundreds of thousands of people were mobilized to dig trenches and to create terraces for supporting trees on barren mountains. Today forests cover 65% of the country, an area of roughly 6 million hectares. Conserving and rebuilding soils. Preserving the biological productivity of highly erodible cropland depends on planting it in grass or trees before it becomes wasteland. The 1930s Dust Bowl that threatened to turn the US Great Plains into a vast desert was a traumatic experience that led to revolutionary changes in American agricultural practices, including the planting of tree shelter belts, rows of trees planted beside fields to slow wind and thus reduce wind erosion, and strip cropping, the planting of wheat on alternate strips with fallowed land each year. Strip cropping permits soil moisture to accumulate on the fallowed strips, while the alternating planted strips reduce wind speed and hence erosion on the idled land. U.S. soil conservation. In 1985, the U.S. Congress, with strong support from the environmental community, created the Conservation Reserve Program, CRP, to reduce soil erosion and control overproduction of basic commodities. By 1990 there were some 14 million hectares, 35 million acres, of highly erodible land with permanent vegetative cover under 10-year contracts. Under this program, farmers were paid to plant fragile cropland to grass or trees. The retirement of 14 million hectares under the CRP, together with the use of conservation practices on 37% of all cropland, reduced US soil erosion from 3.1 billion tons to 1.9 billion tons during the 15 years between 1982 and 1997. The US approach offers a model for the rest of the world. Conservation tillage, both no-till and minimum tillage. Farmers simply drill seeds directly through crop residues into undisturbed soil, controlling weeds with herbicides, leaving the remainder of the soil undisturbed, covered by crop residues, and thus resistant to both water and wind erosion. In addition to reducing erosion, this practice helps retain water, raises soil carbon content, and reduces energy use. 1990s Soil Conservation Plan required. No-till area went from 7 million hectares in 1990 to 25 million hectares in 2004, a 4 times increase. Now widely used in the production of corn and soybeans. No-till has spread rapidly in the Western Hemisphere. Sub-Saharan Africa. Desert moving southward all across the Sahel, from Senegal on the west coast to Djibouti on the east coast. Growing displacement of people as grasslands and croplands turn to desert. African Union has launched the Green Wall Sahara Initiative. Calls for the planting of 300 million trees on 3 million hectares of land. In a long band stretching across Africa. China. China is likewise planting a belt of trees to protect land from the expanding Gobi Desert. Projected to reach some 4,480 kilometers, 2,800 miles, in length, stretching from outer Beijing through Inner Mongolia. China is paying farmers in the threatened provinces to plant their cropland in trees. The goal is to plant trees on 10 million hectares of grainland, easily 1/10 of China's current grainland area. China. The Heilin County, Inner Mongolia, strategy centers on replacing the large number of sheep and goats with dairy cattle, increasing the number of dairy animals from 30,000 in 2002 to 150,000 by 2007. A 5 times change toward cattle. The cattle are kept within restricted areas, feeding on corn stalks, wheat straw, and the harvest from a drought-tolerant forage crop resembling alfalfa, which is grown on reclaimed land. Local officials estimate that this program will double incomes within the county during this decade. 1. Reduce herd size. 2. Bring the forage to them. The only viable way to eliminate overgrazing on the 2/5 of the Earth's land surface classified as rangelands is to reduce the size of flocks and herds. Not only do the excessive numbers of cattle, and particularly sheep and goats, remove the vegetation, but their hoofs pulverize the protective crust of soil that is formed by rainfall and that naturally checks wind erosion. In some situations, the only viable option is to keep the animals in restricted areas, bringing the forage to them. India, which has successfully adopted this practice for its thriving dairy industry, is a model for other countries. Need a worldwide ban on the clear-cutting of forests, in favor of selective harvesting. With each clear cut there are heavy soil losses until the forest regenerates. Thus with each subsequent cutting, productivity declines further. Restoring the Earth's tree and grass cover, as well as practicing conservation agriculture, protects soil from erosion, reduces flooding, and sequesters carbon. It is one way we can restore the Earth, so that it can support the next generations. Regenerating fisheries, reserves that cover 30% of the world's oceans, would cost $12-14 billion a year. This did not take into account the likely additional income from recovering fisheries, which would reduce the actual cost. Would create more than 1 million jobs. Annual oceanic fish catch worth $70-80 billion. Our study suggests that we could afford to conserve the seas and their resources in perpetuity, and for less than we are now spending on subsidies to exploit them unsustainably. If you put areas off limits to fishing, there is no more effective way of allowing things to live longer, grow larger, and produce more offspring. Case studies. Snapper fishery off the coast of New England. Local population of snapper increase 40-fold. Gulf of Maine. All fishing methods that put ground fish at risk were banned within 3 marine reserves totaling 17,000 square kilometers. Scallops flourished in this undisturbed environment, and their populations increased by up to 14-fold within 5 years. Greatly increased the scallop population outside the reserves. Within a year or two of establishing a marine reserve, population densities increased 91%, average fish size went up 31%, and species diversity rose 20 to 40%. Reduce fertilizer runoff and untreated sewage. Creates the world's 200 or so dead zones. Eliminate fishery subsidies. Now so many fishing trawlers that their catch potential is nearly double any yield the oceans can sustain. Managing a network of marine reserves governing 30% of the oceans will cost only $12-14 billion, less than the $22 billion in harmful subsidies that governments dole out today to fishers. Protecting plant and animal diversity. 2 steps essential to protecting the Earth's extraordinary biological diversity are the stabilization of both the human population and the Earth's climate. If the world's population increases to 9 billion by mid-century as projected, countless more plant and animal species may simply be crowded off the planet. If carbon dioxide levels and temperatures continue to rise, every ecosystem will change. Protecting plant and animal diversity. As it becomes more difficult to raise land productivity, continuing population growth will force farmers to clear ever more tropical forests in the Amazon and Congo basins and the outer islands of Indonesia. 3. Water management for fish. At a time of growing water shortages, key to protecting freshwater and marine species, when rivers are drained dry to satisfy growing human needs for irrigation, and for urban water, fish species cannot survive. 4. Parks and reserves. Some 13% of the Earth's land area is now included in parks and nature preserves. Many exist only on paper. Biodiversity hotspots, especially rich biologically. The 34 hotspots identified once covered nearly 16% of the Earth's land surface, but, largely because of habitat destruction, they now cover less than 3%. 1973 The United States Endangered Species Act prohibited any activities, such as clearing new land for agriculture and housing developments or draining wetlands, that would threaten an endangered species. Potential leverage point in battling global warming, because of the need to protect species particularly threatened by warmer temperatures, including coral and polar bears. If we cannot stabilize human numbers and stabilize the climate, there is not an ecosystem on Earth that we can save. Planting trees to sequester carbon. As of 2007, the shrinking forests in the tropical regions were releasing 2.2 billion tons of carbon per year. Meanwhile, expanding forests in the temperate regions were absorbing 0.7 billion tons of carbon annually. On balance, a net of some 1.5 billion tons of carbon were being released into the atmosphere each year, contributing to global warming. Tropical deforestation. Asia is driven primarily by the fast-growing demand for timber. Latin America, by contrast, it is the growing demand for soybeans and beef that is deforesting the Amazon. Africa, it is mostly the gathering of fuel wood and the clearing of new land for agriculture as existing cropland is degraded and abandoned. Two countries, Indonesia and Brazil, account for more than half of all deforestation. Plan B goals. 1. End net deforestation worldwide. 2. Sequester carbon through a variety of tree planting initiatives. 3. Adoption of improved agricultural land management practices. Today, because the Earth's forests are shrinking, they are a major source of CO2. The goal is to expand the Earth's tree cover, growing more trees to soak up CO2. Environmental reasons have pushed bans. Thailand, the Philippines, and China. All three bans were imposed following devastating floods and mudslides resulting from the loss of forest cover. Record losses from several weeks of non-stop flooding in the Yangtze River Basin through those of society as a whole. It simply did not make economic sense to continue deforesting. The flood control service of trees standing, they said, was 3 times as valuable as the timber from trees cut. Beijing then took the unusual step of paying the loggers to become tree planters to reforest instead of deforest. Brazil's Amazon rainforest. If it continues to shrink, it will also continue to dry out, becoming vulnerable to fire. If the Amazon rainforest disappears, it would be replaced largely by desert and scrub forestland. The capacity of the rainforest to cycle water to the interior, including to the agricultural areas to the south, would be lost. At this point, a fast unfolding local environmental calamity would become an economic disaster, and because the burning Amazon would release billions of tons of carbon into the atmosphere, it would accelerate global warming. Deforestation a global concern now, no longer just a matter of local flooding, but also rising seas worldwide, and the many other effects of climate change. Nature has just raised the ante on protecting forests. Reaching zero net deforestation will require reducing the pressures to deforest that come from population growth, rising affluence, the construction of ethanol distilleries and biodiesel refineries, and the fast-growing use of paper. Halting population growth as soon as possible, and, for the Earth's affluent residents who are responsible for the growing demand for beef and soybeans, that is deforesting the Amazon basin, it means moving down the food chain. May require a ban on the construction of additional biodiesel refineries and ethanol distilleries. Potential for foresting wasteland to sequester carbon. There are 1.86 billion hectares of degraded land in the world. Half of this, or 930 million hectares, has a decent chance of being profitably reclaimed. 840 million hectares, 91% of this total, are in the tropical regions, where reclamation would mean much higher rates, 4 times, of carbon sequestration. Maximum technical potential of these 930 million hectares is to absorb roughly 21.6 billion tons of CO2 per year, about 2/3 of what we put up there every year. Potential for foresting wasteland to sequester carbon. If carbon sequestration were valued at $210 per ton of carbon, an estimated 18% of this technical potential could be realized. This would mean planting 171 million hectares of land to trees would sequester 3.5 billion tons of CO2 per year, or over 950 million tons of carbon. Potential for foresting wasteland to sequester carbon. The total cost of sequestering carbon at $210 per ton would be $200 billion. Spread over a decade, this would mean investing $20 billion a year to give climate stabilization a large and potentially decisive boost. This plan to remove atmospheric CO2, most of it put there by industrial countries, would be funded by them. Billion Tree Campaign. Inspired by Kenyan Nobel laureate Winger Mathur, had earlier organized women in Kenya and several nearby countries to plant 30 million trees. As of October 2007, that it had received pledges to plant a total of 1.2 billion trees by year-end. 431 million already had been planted. Mexico pledged to plant 250 million trees. Ethiopia promised to plant 60 million trees. Senegal signed up for 20 million trees. Study of Cheyenne, Wyoming, to Berkeley, California. For every dollar spent on planting and caring for trees, the benefits to the community exceeded $2. A mature tree canopy in a city shades buildings and can reduce air temperatures by 5 to 10 degrees Fahrenheit, thus reducing the energy needed for air conditioning. In cities with severe winters like Cheyenne, the reduction of winter wind speed by evergreen trees cuts heating costs. Real estate values on tree-lined streets are typically 3 to 6% higher than where there are few or no trees. The Earth Restoration Budget. Reforest the earth, protect topsoil, restore rangelands and fisheries, stabilize water tables, and protect biological diversity. Note, forested area is already expanding in the northern hemisphere's industrial countries. Reforestation costs. The focus is on developing countries. Meeting the growing fuel wood demand in developing countries will require an estimated 55 million additional hectares of forested area. Conserving soils and restoring hydrological stability would require roughly another 100 million hectares located in thousands of watersheds in developing countries. An additional 30 million hectares will be needed to produce lumber, paper, and other forest products. Reforestation costs. The focus is on developing countries. Only a small share from plantations. Mostly on outskirts of villages, along field boundaries and roads, on small plots of marginal land, and on denuded hillsides. Labor for this will be local, some will be paid labor, some volunteer. Much of it will be rural off-season labor. Reforestation costs. The focus is on developing countries. Seedlings cost $40 per thousand, 4 cents each, $80 per hectare, at 2,000 seedlings per hectare. Planting labor largely voluntary, $400 per hectare including seedlings. With a total of 150 million hectares to be planted over the next decade, this will come to roughly 15 million hectares per year at $400 each for an annual expenditure of $6 billion. Reducing erosion to the rate of new soil formation or below. 2 principal steps. First, retire the highly erodible land that cannot sustain cultivation. The estimated 1/10 of the world's cropland that accounts for perhaps half of all excess erosion. For the United States, that has meant retiring 14 million hectares, $125 per hectare. In total annual payments to farmers to plant this land in grass or trees under 10-year contracts approach $2 billion. Second, conservation practices on vulnerable land that is subject to excessive erosion, that is, erosion that exceeds the natural rate of new soil formation. Incentives to encourage farmers to adopt conservation practices such as contour farming, strip cropping, and, increasingly, minimum till or no-till farming in the United States total roughly $1 billion per year. The total for the world, to retire vulnerable land would be roughly $16 billion annually. Rangeland protection and restoration. UN estimates that it would cost roughly $183 billion over a 20-year restoration period or $9 billion per year. Improved rangeland management, financial incentives to eliminate overstocking, and revegetation with appropriate rest periods, when grazing would be banned. Every dollar invested in rangeland restoration yields a return of $2.50 in income from the increased productivity of the rangeland ecosystem. Restoring rangelands. Countries with large pastoral populations, where the rangeland deterioration is concentrated, are invariably among the world's poorest. Ignoring the deterioration brings a loss not only of land productivity but of livelihood, and ultimately leads to millions of refugees. Restoration of oceanic fisheries. Establishment of a worldwide network of marine reserves, which would cover roughly 30% of the ocean's surface. Estimated range of expenditures centers on $13 billion per year. Wildlife protection. Shortfall in funding needed to manage and to protect existing areas designated as parks comes to roughly $25 billion a year. Additional areas needed, including those encompassing the biologically diverse hotspots not yet included in designated parks, would cost perhaps another $6 billion a year, yielding a total of $31 billion. Stabilizing water tables. The key to stabilizing water tables is raising water productivity. Research to develop more water-efficient irrigation practices and technologies, dissemination of these research findings to farmers, economic incentives that encourage farmers to adopt and use these improved irrigation practices and technologies. Only about 1/5 of the world's cropland is irrigated. Stabilizing water tables. Disseminating the results. Work through agricultural extension services. Work through the water users associations. Requires knowledge of the amount of water being pumped and aquifer recharge rates. In most countries this information is simply not available. May mean installing meters on irrigation well pumps, as has been done in Jordan and Mexico. Removing subsidies will effectively raise the price of water, thus encouraging its more efficient use. It will take additional expenditures of $10 billion. Restoring the Earth. Restoring the Earth will require additional expenditures of $113 billion per year. Many will ask, can the world afford this? But the only appropriate question is, can the world afford to not make these investments? Bottom line highlights. Protect, restore forests. Reduce wood use. Recycle paper. Efficient third world stoves, energy, wood, sun, wind. Sustainable forestry. Reconstituted wood. Equatorial tree plantations. Reforest waste, eroded land. Conserve, rebuild soils. Conservation tillage. Reduce herd size. Bring forage to herd. Global clear-cut ban. Regenerate fisheries. Reduce fertilizer, sewage runoff. End fishery subsidies. Protect diversity. Water management, for fish. Parks, reserves. Plant trees to sequester carbon, billions. End deforestation.